Hi everyone. Today I'm going to explain the most used concept in statistics, that is population and sample. A population is the entire group you want to study, whereas a sample is a smaller part or a representative part of that group that you actually collect data from. So let's begin. Let's consider a real life situation to help understand population versus sample. So let's start with the problem. Imagine you are a quality control manager at a factory that produces 10,000 light bulbs per day. So, you need to know what is the average lifespan of today's bulb. So, to check the average lifespan of today's bulb, you need to test them. So, do you screw every single one of the 10,000 bulbs into a socket and wait for them to burn out? As we know that the average lifespan of a quality bulb is from 15,000 hours to 50,000 hours. So this is not possible. And of course, we will not check it like this. What we will do, we cannot test all 10,000 bulbs by plugging them in and waiting for each one to burn out. That would take days, cost money, and destroy all the bulbs. So we'll take sample. You will select a sample, maybe 50 or 100 bulbs. That is a small portion. Test their lifespan and use that information to estimate the average lifespan of 10,000 bulbs. So this brings us to the two most important words in statistics, that is population and sample. Hence, in statistics, we cannot study everything. So we study part of it. So let's define population and sample. First is the population. Now, the population is the entire group that we want to draw conclusion about. It is the complete collection of all individuals, items, or data points that we are interested in studying. What are the key characteristics of the population? So the key characteristics include, it is defined by the research question. We typically denote the size of the population with capital N, and it uses parameter, whereas a parameter is a numerical measurement describing a characteristic of a population. For example, the true average lifespan of all 10,000 bulbs in the above case. Okay, the sample. The sample is the subset of the population, a small part of the population, but a representative part, subset of the population that we actually collect data from. It is the group we observe to gain insights about the population. That is, we want to know about the population with the help of sample, because we cannot study population easily as we study sample. The key characteristics of the sample include it is manageable, measurable, and ideally representative. Uh, we denote its size with the small n, and a numerical value calculated from the sample is called a statistic. For example, in the above case, average lifespan of 50 would be a statistic. So we use statistic from the sample to estimate a parameter from the population. So in the above example, here n is equal to 10,000 because this is the size of the population, 10,000, whereas small n is equal to 50 because we are going to take a sample of 50 from this 10,000 because it is difficult to study this 10,000 light bulbs. So small n is equal to 50. Now the numerical value calculated from this n is called parameter, which is denoted with mu, that is like this. Mu is equal to summation x divided by capital N. So this mu is the parameter, and a numerical value calculated from this small size, that is the sample, is denoted with x bar, and its formula is summation x divided by small n. So this x bar is called statistic. So this will talk about average lifespan of 50 bulbs, and this will talk about average lifespan of 10,000 light bulbs. Now we use this sample to talk about this population. So if this sample is a representative sample, then we will correctly estimate, or we will correctly identify the average lifespan of all 10,000 light bulbs. Okay. Here is the example or image of population versus sample. So this is the target population. Now if we want to study these all individuals, so this would be not possible because it will take time and it will be expensive. So we can take a sample out of it, but a sample must be representative. Why representative? Because a sample must be from every subgroup, section, category or batch within the population, must have a fair chance of being included in the sample. Example, in the above 10,000 bulbs and taking out 50 sample out of this 10,000 bulb, this 50 sample bulbs will be representative if it must include bulbs from different machines, different batches, different times of the day, different workers or assembly line if applicable. If you only take bulbs from one machine or one box, so then it is not representative and it doesn't include all parts of the population. Similarly, if this sample is taken from one part of this image, so this would not be a representative sample. So representativeness is a must in a for a sample. Okay, now the question is, why don't we study the entire population? So here are some reasons that we cannot study the entire population, although the results are accurate if we study the whole population, but that is not possible. And due to these three main reasons, it is not possible to study the whole population. The first one is cost. So studying every single item in the population is usually too expensive. Next one is time. Studying the whole population takes too much time. The third one is infeasibility. So sometimes it is not practical or not possible to study the entire population. That is, you cannot test all bulbs because you would destroy them. Like if you want to test, or if you test 10,000 bulbs, then you destroy the 10,000 bulbs. In the above example, you cannot ask every person in a country their opinion. You cannot measure every fish in the ocean. So a sample is the only realistic option for such cases. Okay. Now let's discuss representativeness. Why it is necessary for a sample to be representative of the population. So a sample is only useful if it is representative of the population. A representative sample has the same characteristics as the population, just on a smaller scale. So if a sample is not representative, we call that bias. So for example, or let's consider a tale. Here is a story, and in this case, the sample was not representative, so the result was quite embarrassing for this journal. This is a story of a journal. So this journal, Literally Digest, sent questionnaire to 10 million people within USA. But the problem was that 10 million people were registered to them. Like they were readers of this journal, or they were car owners, and they were listed in the telephone directory. So 2.4 million responses were received to this, and the question was about who will win the election, presidential election, and the competition was among Lyndon and Roosevelt, and this was a presidential election. So according to this journal conclusion, on the basis of these 2.4 million responses, 57% favored that Lyndon will be elected for the presidential post, while 43% opinion was about Roosevelt. But what happened when actually the poll conducted and the result came, then Roosevelt won with 61% margin, and Lyndon lose the election with 37% of votes. the magazine prediction said Alf Landon would win, but in reality, Roosevelt won by a landslide. This was because uh, of the non-representativeness. So this became a famous failure in statistics. Now, why was the prediction wrong? The prediction was wrong because their sample was not representative. They selected people from telephone directories, club memberships, magazine subscribers, and automobile registrations. But if you go to the time of 1936, so in 1936, these such group of people mostly included wealthy, or mostly they were wealthy people, and wealthy people were more likely to vote for Landon. So this was not representative. So even though the sample was very large, it was biased. So this means that a large sample doesn't guarantee accuracy. If the sample is biased, the results will be wrong. And representative sample is more important than sample size. A large sample does not guarantee accuracy. A representative sample does. So this was a big failure for this journal. Now, how to achieve a representative sample? So for this, we use the term randomization. So randomization is the only tool to achieve a representative sample. So what is a randomization? So to avoid bias, we rely on random sampling. Randomness is not chaos. It is a mathematical process that ensures every member of the population has a known non-zero chance of being selected. So hope you got the lecture. Now you can do this exercise in which you have a question: if I have a large enough sample, does it automatically represent the population? So here's the answer for you. In the above case, if a sample is large enough, in the above case it was 2.4 million, but still it produces wrong results, or it generated wrong results. So size doesn't matter, accuracy or representativeness or randomness matters. So here is an assignment for you in which you need to define a research question in your field of study or hobby, which clear state that what is the population, what would be a sample, why is a parameter you would want to estimate, what is the corresponding statistic you would calculate, identify one potential source of bias in your sampling plan, and explain how you might use randomization to fix it. So you can use the above lecture to answer or to do this assignment. So hope for the best of luck to you. Thank you, and see you in the next lecture.